Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 33, and this is lecture number 11 of the physical chemistry chapter liquid state. Here we are in the fifth lecture of the subtopic viscosity of liquid. Here we are going to discuss the Stokes law and the falling sphere viscometer method. This is a tool by which the viscosity of a liquid is measured. For that we have to take help of a law which is known as the Stokes law. We're not going to derive that law, but we'll take help of that law for deriving this method. Suppose this is a metallic ball and this is a liquid column, and on the top of the liquid column the metallic ball is released and it starts falling to the downward direction. After traveling a little distance, it will attain a zero acceleration, that is a uniform velocity. At this point, the ball is said to have a steady state. Here, two opposing forces are acting together, and at steady state, these two forces are equal. So, we have to take help of the Stokes law, which is describing the viscous force on the falling sphere, which is taking place in the upward direction. That is the opposing force. The ball is trying to fall in the downward direction, but the liquid is opposing that downfall. So for that an equation is required which is known as the Stokes law, and the Stokes law says that this force is 6 pi r eta u. So what about the physical significance of these symbols? R is the radius of the falling sphere, eta is the viscosity of the liquid medium, whereas u is the velocity, but this velocity of the falling sphere must be uniform, that is, it should have a zero acceleration. The gravitational force felt by the falling sphere must be mg, and this is taking place in the downward direction. So this is force F1, which is taking place in the upward direction due to the viscosity of the liquid, and this is the downward force, this is due to the gravitational acceleration. And if m is the mass of this sphere, then mg is the force. These two forces are at equilibrium, are equal at steady state. Now what about the value of m? Now this m is not this actual mass of that ball. It is the relative mass of the falling sphere or the ball. How would you calculate? Simply the difference of the masses of the two liquids at a particular volume. So how do you calculate that? Simply if you multiply the density difference with their volume, then you will get the relative mass. Look how this is the volume into density difference. What is the volume of the sphere? It is 4 by 3 pi r cube. And what is the density difference? Rho minus rho 0. Rho is the density of the ball and rho 0 is the density of the medium. And g is, as usual, gravitational acceleration. Therefore the force F2, that is the mg force, is actually can be written as 4 by 3 pi r cube rho minus rho 0 g. At steady state, that is when the sphere attains a uniform velocity, the two opposing forces F1 and F2 becomes equal. Therefore F1 equals to F2, that is 6 pi r eta u equals to 4 by 3 pi r cube rho minus rho 0 g. So after rearranging this, we get the expression of eta, which is twice r squared rho minus rho 0 g by 9u, and this is equation number 15, and this is the law by which the viscosity of a liquid by falling sphere method can be determined. Now here we are carrying forward this equation number 15, and in this equation, look which the velocity u can also be written as L by t. What is L? Look at this picture. The distance from here to here, where the uniform velocity is maintained, if this distance is L and t time is taken for the ball to fall from this point to this point, then L by t is u. So in place of u we can write L by t. Now look, if two different liquids are taken which have two different viscosities, eta 1 and eta 2, then in that case, if we take the same sphere, then r must be constant term, g is definitely a constant, this rho must be constant because this is the density of the falling sphere, whereas this rho 0 is variable because you are using two different liquids. For liquid 1 it may be rho 1, for liquid 2 it may be rho 2. This L must be constant because we are indicating the same distance, or we are marking the same distance, whereas the T must be different because the liquids are different, so they will allow different time for the ball to fall for traveling a particular distance L. So look, which are the variable terms and which are the constant terms. The red color terms are the variable terms, whereas the blue color terms are the constant terms. So if we compare the viscosities of two liquids as eta 1 over eta 2, then we can get this equation: eta 1 over eta 2 equals to rho minus rho 1 over rho minus rho 2 into T1 by T2, where eta 1 and eta 2 are the viscosities of the two liquids, rho 1 and rho 2 are the corresponding densities of the two liquids, whereas T1 and T2 are the times taken by the falling sphere for the two liquids. So that's all for this lecture. Thank you. Have a nice day.